So we get into now the NFPA 704 placard system. Now in this particular system, what we are looking at is a system that has 4 different diamonds inside of a larger diamond. The 4 different diamonds are different colors, and each color has a representation for a different type of hazard. So you can see that here we have a blue diamond, which indicates health. We have a red diamond. Okay. We have a red diamond here to indicate flammability danger. You have a yellow diamond here to indicate reactivity. And then we have a white diamond here that indicates any other kinds of special hazards. If you watched the safety video in lab on Friday, you'll know from that video that each one of those areas is rated from 0 to 4. Zero is an indication that there is no hazard associated with that particular color. 4 indicates an extreme hazard of some sort. And the areas in between all are obviously in between. So if you have something that is 0 in health, that is something that we would identify generally as non-toxic. A 0 in flammability would mean that it does not ignite under really any circumstance. A 0 in reactivity means that it is extremely stable. But a 4 in health means that it has a very acute toxicity and can be deadly in either very, very small doses or very, very small exposures, or both. A 4 in flammability means that it will flash below room temperature. And a yellow reactivity rating of 4 means that it is highly explosive. So obviously the 1, 2, and 3s for each of those colors kind of fit in between. And let's look at each one of those a little bit more individually. So for red, red is always on the top of the diamond. It is a flammability rating. Those flammability ratings are based upon flash points. That is the temperature where there's enough vapor present that we can get a reaction, a flame to ignite, at least temporarily. Again, the classes here, class 4 has a flash point below 73 degrees Fahrenheit. The reason 73 degrees Fahrenheit was chosen is because that is a commonly understood room temperature measurement, 73 degrees. So if it is class 4, it'll flash below that. If it is class 3, it'll flash somewhere between room temperature and 100 Fahrenheit. If it's class 2, it'll flash between 100 Fahrenheit and 200 Fahrenheit. And if it's class 1, it'll flash above 200 Fahrenheit. If it is class 0, it simply will not burn. So, water, for example, is a class 0 flammable material. For yellow, we are looking at reactivity. The reactivity of a substance, so this is the right-hand diamond. The reactivity rating is based upon the explosive nature of the material. So what we're really getting after with reactivity here is stability, explosive character. So a class 4 reactive material is explosive. A class 3 material, if there is shock and heat present, it might detonate. So it's not truly an explosive, but if the conditions are right, it could be. If it's class 2, it is unstable and could potentially react with water. So you see a number of those dangerous when wet materials falling under the 2 rating for reactivity. For number one, it is unstable when heated, so it can either decompose or produce a gas or do some other things under heat. And if it's class 0, again, it is stable. Blue is your health hazard. Health hazards, again, are related to toxicity. Now, the meanings here, you can see that of the different ratings that we were looking at, these ones are the least specific. A class 4 material is considered extremely toxic. A class 3 material is considered seriously toxic. A class 2 material is considered moderately toxic. A class 1 is considered slightly toxic. A class 0 is considered non-toxic. Again, the lines of demarcation here aren't nearly as well defined as they are for the red or the yellow. But we still should be able to understand the graduation system here. If it's 4, watch out. If it's 0, don't worry about it. If it's somewhere in the middle, you need to take the appropriate amount of caution. And then for the white, with white we have special hazards. And so this is always the bottom diamond. And these are just any things that we might consider notable about this particular hazardous material. So, for example, we might say that something is an oxidizer. And so we would classify it by putting OXY in that bottom diamond. Or we might say it's an acid or a base. Acid we would mark with acid, bases we would mark as alkaline instead. This particular one here, the W with a slash through it, indicates that this is a substance that cannot come into contact with water. If it comes into contact with water, it can behave quite violently. So if you see that W with a line through it, that means it cannot go through water. It cannot be in water. It cannot be stored in water. You shouldn't try to put it near water. COR indicates that something is corrosive. And then we have here the biohazard symbol to indicate something that is a living biohazard and harmful to health and well-being and plant and animal matter. And then we've got the trefoil sign here for radioactive materials. Now, it is possible to have multiple of these in the same white diamond. So it is possible for something to be corrosive and an oxidizer, or to be an acid and an oxidizer, or to be corrosive and not be able to come in contact with water. So there are combinations here that are allowed as well. But that's where you're going to see those white diamonds. So we come now to the Global Harmonization System. Global Harmonization System is a unified system for international labeling standards and classification. It was first adopted in 2008 for use on MSDS by OSHA. We are going through a rather long and drawn-out process of converting. And so one of those steps of conversion was to convert MSDS into SDS, the safety data sheets. And if you recall from Friday, when we looked at those safety data sheets, we saw a lot of placards that had this kind of an appearance. a diamond shape that was outlined in a reddish orange kind of color, and then had some sort of pictogram in the middle. Those are the global harmonization diamonds. And so they all have that in common. They are all diamond shaped. They all have a reddish orange outline, and they have a black and white pictogram in the middle. That is the global harmonization system. Now, as far as hazard classes are considered, the Global Harmonized System recognizes 29 different classes of hazards, 16 of which are physical hazards, 10 of which are health hazards, and 3 of which are environmental hazards. Now, those environmental hazards, it's important to know, are not required for labeling by the DOT or by OSHA. So it is going to be much rarer to see those environmental hazard placards on materials that are shipped here domestically. However, we will see these other 26 classes represented prominently. Now, the thing that you might be asking yourself is, well, hold on a second. If there are 26 different classes, 29 technically, does that mean that there are 26 or 29 different placards? And the answer there is actually no. A number of different placards, a number of different pictograms will represent multiples of these hazards in their kind of overall description. So let's take a look at those. Now, the hazardous communication, the GHS hazard communication, kind of like the HAZCOM law here in the United States, says that once a chemical has been classified into one of these subclasses or multiple subclasses, the hazards have to be communicated to the target audiences. Where they get brought in are either in labels or safety data sheets, or in most cases, both. But at minimum, any workplace, laboratory, or otherwise is going to need to have safety data sheets on hand and available, ready to go to communicate the hazards to the people, the workers involved. Labeling, most have appropriate labels, but once we get into secondary and tertiary bottling, where we're taking some sort of substance that came from the manufacturer, let's say that it's in a 40-gallon drum. Well, chances are you're not going to have people just dipping into that 40-gallon drum to take things out. Maybe they convert it into, from the 40-gallon drum that is properly labeled and everything, to a 4-gallon container. And then from the 4-gallon container, they go and they make little half-liter bottles to supplement. Those kinds of things are possible. And technically, according to the GHS, each one of those bottles, both the 4-gallon sub bottle and the little half-liter bottles, should have a proper label. However, in actual practice, what we will find is that that is not always the easiest thing to do and the easiest thing to keep up with. But if we at least label those smaller bottles properly with, here's what it is, here's what its concentration is, here's the manufacturer, then someone can go and look at the safety data sheets and at least get the information that they need that way. Part of that labeling system is the use of signal words. We've talked about signal words, at least in small part already. The two primary signal words are danger and warning, and they're used to primarily emphasize hazards and indicate just how severe the hazard actually is, based upon what class of hazard is being dictated here. Now, in particular, we are looking at two different types of words. For danger, danger is going to indicate a more severe hazard. Warning is going to convey a less severe hazard. But if either are present, we do have to take special care to make sure that we are addressing the hazards and dealing with them properly. So if you find that a warning label doesn't have either of these danger words, either of these signal words, understand that the danger there is considerably less. If you see a signal word of any kind, treat that material with more special attention, more caution than you would any other common material. And obviously, if it says danger instead of warning, make sure that you really have an understanding of what you're using before you use it and what kinds of personal protective equipment are necessary for the job. As we've seen with the DOT system, symbols and pictograms are a large part of the Global Harmonized System. They help to convey the physical, the environmental, the health hazards associated with a particular hazard class. And these symbols and pictograms are not only used in SDSs, but they are also to be used in labeling as well. As I mentioned before, the pictograms themselves are going to have some kind of black symbol on them with a white background and a red diamond frame. So a generic kind of look is something along these lines. I've got my red diamond. Now I'm going to draw a symbol. And so that's going to convey some kind of image there. I was going for the flaming circle for oxidizer. I don't think I actually did it very much justice, but you can make that determination on your own while you're laughing at me when you're watching the slate. Let's look at the actual hazards themselves. So for health hazards, there are two primary pictograms for health hazards. This one is known generally as the exploding heart pictogram. And the health hazards that are communicated by this particular pictogram are as follows. This can be used for anything that is a carcinogen, meaning that it could cause cancer. A mutagen, meaning that it could mutate your genes in your DNA. A reproductive toxin, meaning that it could affect your ability to reproduce or affect your sexual organs in some way toward making them impotent or sterile. Respiratory sensitizers, meaning that they would affect your lungs in some kind of negative way. Target organ toxicity, maybe this particular material will target your liver or target your thyroid gland or target your kidneys. And aspiration toxicity, something that will affect your upper respiratory and your throat area that can actually cause you to start to ingest things or start to throw up things that are supposed to go into your stomach, but end up going into your lungs or vice versa, and could end up causing you to choke. So these are 6 health hazards that are all associated with this one particular pictogram. Again, it's the exploding heart pictogram that we're looking at here. Here's an example of an environmental toxin. Again, environmental pictograms are not required for use in the United States. I'm showing it here merely just to make you aware, especially if you work with anything that comes from foreign manufacturers. You might see this. This particular pictogram indicates aquatic toxicity, and we can kind of see it through here with the, we've got our body of water that has turned black. We've got our dead fish and our dead tree next to that river, which indicate that the water is poisoned in some kind of way. The second type of health hazard pictogram is the exclamation mark. That is obviously the name of this pictogram as well. What the exclamation mark indicates are things that are irritants, things that will cause damage to your skin or your eyes, things that will have skin sensitivity, things that are acutely toxic, meaning that they will cause death or impairment in small doses, things that might cause narcotic effects where they affect your brain chemistry in some kind of way, things that will irritate your respiratory tract. So not quite the same thing as what we saw in the previous, where we had a respiratory sensitizer that would cause severe damage to your lungs and your other parts of your respiratory system. But things that would cause irritation, cause burning sensations, possibly cause bigger damages if the exposure was prolonged, and things that are hazardous to the ozone layer. And again, this last one is not a requirement here in the United States, but this could be used to indicate that hazard as well. And then finally, we get to the skull and crossbones, which indicate an acute toxicity, either fatal or severely impaired in terms of its toxicity. Other pictograms, so those are primarily your health hazard pictograms. Again, there were three. There was the health hazard, the exploding heart, the exclamation mark, and the skull and crossbones. For physical hazards, we have the gas cylinder. Gas cylinder indicates that there are gases being held under high pressure. And so we have to be aware and take special precautions when dealing with materials around there. Make sure that we do not rupture the cylinder or cause the gas to come out in a uncontrolled fashion. There are also corrosion. So with corrosion, again, look at the pictogram here. This is the same pictogram that are used for Class 8 hazards in the Department of Transportation system. We've got the chemical that is eating through the metal and burning the hands. What we'll see here is that this material can cause skin corrosion or burns. It can cause eye damage if it happens to get into your eyes. It can cause damage to metallic materials if it encounters metals. The exploding bomb pictogram here indicates that we have an explosive material. It also indicates things that could be potentially self-reactive. We talked about those a little bit in our Class 4 hazards, the flammable solids, where they can decompose and create their own oxidizer, their own reactors. Organic peroxide, same kind of thing, where the peroxide can actually create its own fuel in addition to creating its own oxidizer. Flame over circle, and boy, did I do a bad job on that in retrospect. This indicates oxidizers of some kind. So again, the pictogram here is exactly the same as what we saw for Class 5 materials in the DOT system. Flame, this is the same kind of pictogram we saw for Classes 2, 3, and 4 in the DOT system. This would indicate flammables, that is anything that could catch on fire potentially. Pyrophorics, things that will ignite on their own. Self-heating materials, things that as they decompose will actually generate enough heat to continue the reaction on its own. And if the reaction proceeds long enough and far enough, will eventually start a fire. Things that will emit flammable gases. So we talked about dangerous when wet. One of the things with dangerous when wet materials in Class 4.3 is that when they come into contact with water, they usually tend to emit some kind of gas that can catch on fire. And if enough of it is emitted, that flammable gas can actually ignite. Self-reactive materials, things again, when conditions are right, will actually cause reactions with themselves, potentially causing fires or explosions. And again, organic peroxides, which we saw in the other one with the flame over circle, because it exists for both. And so from a physical hazard standpoint, we see these 5 particular pictograms: the exploding bomb, the flame over circle, the gas cylinder, the fire pictogram, the corrosion pictogram. And so all of those physical hazards are contained in these 5 pictograms. All of those health hazards are depicted in these 4 pictograms. Notice that the corrosive pictogram is doing double duty, because in the corrosive, we're getting into health hazards. We have health hazards in terms of damage to skin and eyes, but we also have damage to non-health with the ability to corrode materials. And so this is the only one that has that crossover ability, where it'll actually impede on both. And so that is it for the NFPA placard system and the GHS system. Okay, so what I want to do then is, with our remaining few minutes here, let's actually talk about not the placards here, but let's look at, what if you get a question, something like question 11 here, where you've got multiple pieces of information. Okay, so this is a common warning label. This is a warning label for nitric acid. Now, in a quiz or a test situation, so again, if we go to the quiz here, any information that would have been here on the, kind of in the descriptions, I've wiped that off. Because what I want you to do is, you can get almost all of this information, or at least a good chunk of it, just off of the placard itself. And so what I want us to be able to do is, if we are given a blank placard of some kind, where all we're given is the numbers and maybe some special information, or in the case of the quiz, a series of pictograms and an NFPA, can we look at it and say, okay, these are the primary hazards associated with it? So I'm going to pause the share for just a second and find a label that you haven't seen yet. And let's see if we can do what we're supposed to do. Here we are. I've given you limited information about this particular substance. This particular substance is something called oxalic acid. Based upon the pictograms available, can you tell me some hazards associated with this substance? So either raise your hand or throw some thoughts out into the chat. Let's see what we can come up with here. Okay, Kiara has got us started. It's a danger to our skin and to aquatic life. Caleb has added that it's corrosive. All right, Joshua says it's an irritant. Peter's adding that there's maybe some kind of skin element to it. All right, we're on the right track. We're definitely on the right track. So let's start breaking this down kind of piece by piece. Um, so right here, the first part here indicates that we have something that is corrosive. So those of you that said that we are dealing with a corrosive material, you're absolutely correct. Kiara pointed out that we have the aquatic pictogram, which means that it is dangerous to aquatic life. So that's a good one there. Now, those of you who've been kind of eating around the edges of the exclamation point here, this is where the MSDS would be really, really useful to us, because that exclamation point indicates a wide variety of different health hazards. But we know that it's probably some kind of an irritant. Chances are pretty good that skin irritation is going to be a real possibility, because we already know it's corrosive. Corrosives do have effects on your skin and your eyes. So where we would want to look is if we pulled up the safety data sheet, this is what it would tell us. Harmful if swallowed, harmful if in contact with skin, can cause serious eye damage, toxic to terrestrial vertebrates, which would include, people like us. So the only thing that we really kind of missed was we didn't really harp in on this signal word of danger. Now, keep in mind, if you see a signal word, that indicates a level of severity. And so one of the things that we want to do in kind of writing out this warning label, again, kind of use this example that we had as a particular reference. All right. My screen froze, that was great. But if we think about the nitric acid, the nitric acid label gives really specific ideas about what, how to convey the proper level of danger. So, when you're looking at that chapter quiz, kind of those are the kinds of things that you want to keep in mind. Try to use the NFPA placard and these GHS pictograms to try to paint as complete of a picture as you can without knowing exactly what it is. And so in that quiz question, you're writing out your essay, write out as many things that make sense that you can for that material. And then you should be pretty well set. So that's all the time we have for today. I will see you on Wednesday when we talk about Chapter 2. Don't forget about the assignments that are due tomorrow.